triangles congruent? What are some of the ways we can talk about? SSS, ASA, SAS, and AAS, right? We talked about those 4 ways. And yesterday, we also said that really the SSA didn't work. I showed you why, right? That one little picture that we did. And so, we're going to talk a little bit more about that because there is a special case in which the SSA works, okay? What you can see here is another example of an SSA that does not work. I have 2 sides that are 5, I have 2 sides that are 4, I have this 45-degree angle, but these 2 triangles are not the same, okay? I can take and I can, move this side, this QR, and make it bigger or smaller. This would still stay 45, QR would stay 4, and PR would stay 5. This angle would change, but the triangles would necessarily be congruent to each other, okay? So, technically, SSA is not a valid method for proving the triangle is congruent. But there is a special case in the right triangle, and that's what we're going to focus on today. And it is called hypotenuse leg. And so, if the hypotenuse and leg of one right triangle are congruent to the hypotenuse and leg of another right triangle, then the triangles are going to be congruent. Now, a couple of things that you have to have. You have to have congruent hypotenuses, congruent legs, and it has to be a right triangle in order for this to happen. So I've got an example here. Now remember, your hypotenuse is what is across from the right angle in a right triangle. And then your other 2 sides are your legs. And you can be either leg, it doesn't matter which one, but it has to be a set of hypotenuses and a set of legs, and it has to be a right triangle, okay? Alright, so let's look at a couple of examples. It says, state if the 2 triangles are congruent. If they are, state how you know and write a congruent statement. Alright, so looking at number 1 there, are those 2 triangles congruent? We see that these are both right angles, right? These legs are congruent and they share their hypotenuse, right? So, these 2 triangles are congruent by hypotenuse leg. Now, the other ways that we learn aren't extinct. They're still fair game, so you can still use those in what we do today. So, it wants us to write a congruent statement. So, if I said triangle ABD is congruent to, how would I state the other one? If I said ABD, the other one would be ABD. And this one is by hypotenuse leg. Okay, what about number 2? Are these 2 triangles congruent? Why not?
Because there's 2 angles.
Yeah, and we could prove the 3rd angle too, couldn't we? But that's still not going to help us, is it? Because having angles that are the same doesn't prove congruence. So this one is not possible. Alright, how about number 3? Okay, it shows a pair of legs, and when they're right, you've got right angles, and again, they share the hypotenuse, yes? Okay, so these would be congruent by hypotenuse leg. So if I said triangle PQS, that would be congruent to what?
RQS.
I would probably say RSQ here. It looks like it's a rectangle, and when you draw a diagonal in a rectangle, it doesn't necessarily create 2 equal angles. If it was a square, it would, but it's kind of iffy there, so I would probably go the other direction with that. And again, this is by hypotenuse leg. Alright, how about number 4? Not possible? Okay, you're right, you don't know anything about the hypotenuses, but they do share the other leg, yes? You could do hypotenuse leg, but what could you do? Side angle side. So they're still congruent for a different reason. So triangle NPN is congruent to triangle what? OPN. And this time it is by side angle side. Alright. Now the next 2 ask us to state what additional information is required in order to know the triangles are congruent for the reason given. And both of these are hypotenuse leg. In your homework it might be for different reasons, but these 2 are just for hypotenuse leg. So we see we've got a right angle. They share a leg. What else is needed here? The hypotenuse, right? So we need ML to be congruent to XL. And I do want you to state those congruencies. Not, it's good to mark them, but I also want you to state them. Okay, what about number 6? This time we've got right angles, right? Our hypotenuses are congruent. So what'd you say? One of the legs. Does it matter which pair? No. So we can use the small ones, right? And state that LN is congruent to XN. Or we could use the longer ones, which would be MN congruent to WN. Alright, any questions on that one? Alright, so let's do a little proof here. We're trying to prove these two triangles congruent, and so we've got 5 different ways that we can probably go about it. Alright, the first thing that Gibbon tells us is that BE bisects AD at C. What does being bisected? I know, but what's being bisected? BE is bisecting AD at C. So what's congruent? AC and DC, right? And what would my reason be for that? Definition of bisection, right? Okay. Then it tells me that AB is perpendicular to BC and DE is perpendicular to EC. What happens when you have perpendicular lines? You get right angles, right? Now we're going to go a little bit different with this. Instead of stating that those right angles are congruent, I want to establish that those triangles are right triangles. Okay? Sometimes you want to state they're congruent, sometimes you want to state that they're right triangles. It depends on what direction you're going with your proof. Okay? But this one we're probably going to do hypotenuse legs. So we would, once we say that these are right angles, then I can say that these two triangles were right. It would be by the definition of a right triangle. The definition of a right triangle says it's a triangle with at least one right angle. Okay? Alright. And then it tells us that AB is congruent to DE. That's given to me. So is that enough information to prove the triangle's congruent by HL, right? Hypotenuse leg. Okay. So BE bisects AD at C. And that's given to me. AB is perpendicular to BC. AB is perpendicular to BC. DE is perpendicular to EC. And AB is congruent to DE. All of that. So, we have already the AB and the DE is my leg, right? Alright, so from the perpendicular, I want to state my right angles. So I can state that angle B and angle E are right angles. And what's my reason for that? Definition of perpendicular. Then what do I want to say? You could say angle B was congruent to angle E by all right angles are congruent, but we don't necessarily want that in this one. Right. So triangle ABC and triangle DEC are right triangles. And that would be the definition of right triangle. Okay, so that takes care of the right triangle. Oh, I forgot to use the first part of my given. What can I get from that? AC is congruent to DC, right? And what is that? definition of bisector, right? Okay, so that takes care of the hypotenuse, right? So I've got the hypotenuse stated, I have the length stated, and I've stated that it's a right triangle. Is that enough to prove that it's the triangle's congruent? Yes. So I'm going to say that triangle ABC is congruent to triangle DEC. And what's my reason? Hypotenuse leg and so. Yeah, you have to state it's a right triangle. Yeah, in order for you to use hypotenuse leg, yes. All right, are there any questions? Okay, I have a worksheet for you